Today's video is the start of a new unit having to do with exponents. So the first thing we're going to talk about is the multiplication property of exponents, and there's three separate subtopics that fall under that topic. The first one being the product of powers property. So with the product of powers property, that is saying to multiply powers of the same base you add the exponents. Now the important thing here is that they have to have the same base. And what I mean by base, if you're not familiar, if I have some exponent, let's say x to the fifth, this x right here is the base. And then of course this 5 is the exponent. So some examples when you have the product of powers are as follows. First one, let's say that I have x squared times x to the third. So because they both have the same base, they both have a base of x, I can just combine this by adding the exponents. I have a 3 and a 2, so my new value is x to the fifth. Okay, all I did. And why that is, because if you have x squared, you have x times x. And with x cubed, it would be x times x times x. How many x's total do you have? Well, you have 5. Okay. Also, the same thing goes with if you have, you won't really see this very often, but I just want to show you because most of the time if we have 5 cubed, we'll just say what 5 cubed is. But if you have 5 cubed and 5 to the 6th power, again, both of the bases are 5, so that would just equal 5, and then you add 6 plus 3 is 9. Okay, so pretty straightforward. Let's look at a little bit more of a complicated example. Let's say you have x times x squared times x to the third times x to the fourth. What do we have? Well, the first thing we need to remember is that this x right here does have an exponent. It has an exponent of 1. So when you add these all together, you have to add 1 plus 2 plus 3 plus 4. And that gives you x to the 10th. Last example with this is going to be, let's say that you have maybe -2 times -2 to the fourth. Again, because there is no visual exponent with this first -2 doesn't mean that it doesn't have an exponent of 1. This is very much like when you have a variable x and there's nothing in front of it, it has a coefficient of 1. So I can add these together. I have 4 plus 1, so I have -2 to the fifth. Again, you can put this and figure out what number -2 to the fifth is, but I'm just showing you examples with variables and numbers. Okay, so that was the first scenario. The second scenario is the power of a power property. So you have the power of a power property. Okay, and what this says is that to find a power of a power, you multiply the exponents. Okay, so a power of a power. So first, when we're multiplying, we add. Now we are going to multiply the exponents. So a couple examples here. Let's say I had 3 to the fifth, and I want to square that. Well, this is a power of 5 raised to a power of 2. That's where the power of a power comes in. So what it's saying is that I need to multiply these two. So this is equal to 3, 2, 5 times 2 is 10. And another way to look at this, if we had 3 squared, that's technically 3, or 3 to the 5th squared, I'm sorry, that's technically 3 to the 5th times 3 to the 5th. Now, with looking at what we just did, these are the same base, so I can add the exponents. 3, 5 plus 5 is 10. So very different way of looking at it, but that's why the multiplication there works. All right, another example. Let's say I have y squared raised to the 4th. Well, what do I have? 4 times 2, and I would have y to the 8th. Last thing, I could see it maybe if I had p plus 1, right? Now I have, hold on, let me go back. I have p plus 1, and that is squared, and then I can raise this to the 6th power. Well, the rule still applies. I now have p plus 1, and I have that raised to the 12th power. All right, so that's the power of a power. You just need to memorize, when do I add the exponents, when do I multiply the exponents. All right, the last one that we're going to look at today, before we do some practice, is a power of a product property. And we know what product means, right? When you hear the word product, you should think to multiply. So, to find a power of a product, you have to find the power of each factor and multiply. And this will make more sense in just a second when we start looking at some examples. This is very similar to when we distribute. And again, you will see why in just a second. Okay, so when we have a power of a product, so with product, we're going to have numbers and variables being multiplied together and raised to a power. So this is we're going to simplify. All of these questions are us simplifying. We're not solving for anything. We don't have an equation. We have expressions here. So we're just simplifying. First one I'm going to do, let's say I have 4yz. I'm going to make that a z. And that's raised to the 3rd power. So what this means is that I have to go ahead and this power of 3 out here has to be to each one of the factors, right? Things multiplied together are factors. So I have to bring this 3 to the z, to the y, and to the 4. And that's why I say it's very similar to distributing, because that's essentially when you distribute, you're doing kind of similar thing. So this is what's going to happen. I'm going to go 4 to the 3rd, y to the 3rd, and z to the 3rd. Now I know that I can simplify this a little bit further, and that being this 4 to the 3rd. So 4 to the 3rd is actually 64. So this will simplify to 64, y to the 3rd, z to the 3rd. And that is my simplified answer. Okay. Look at a couple more examples. Let's say that I had, let's see, 2x squared y, and I was raising this to the 3rd. Let's look at how that's a little bit different. Again, I am going to bring this 3 inside to all 3 of those factors. So I have 2 to the 3rd. Now here I have x squared and I'm raising that to a 3rd power. So that's similar to when we talked about a power of a power. And if you remember, go back into your notes, when we find a power of a power, we multiply. So I'm going to multiply this 2 times this 3. So it should be x to the 6th and then y to the 3rd. So that would be 2 cubed. 2 times 2 is 4 times 2 is 8. So 2 cubed is 8. X to the 6th, y to the 3rd. All right, so just be careful with that. It essentially is doing the same thing with this y. Let's say there was a 1 here, which there is. There is an invisible 1. We're essentially doing the same thing. because 1 times 3 would give me this 3 over there. Okay, we just have to be careful when we have something other than an invisible 1. All right, a couple more examples. I want to show you kind of two different things. Similar examples, but they're essentially way different. If I have this over here, and I have this over here, how are they different? Are they different? And if so, why? Well, they are extremely different because with this one on the left-hand side, I'm going to bring this 2 inside to each of those. So negative 2 squared, w squared. Negative 2 times negative 2 is 4w. So this simplifies to 4w. Over here, bring down this negative, I have 2 squared w squared. Well, 2 times 2 is 4w, but this negative right here has to come down in front. So now over here I have negative 4w. So this goes back to this thing where I talk about how you have to be very careful with your negatives and making sure that if that's a negative 2 that goes in parentheses, especially when you're inputting these things into the calculator. Okay, so the final thing we're going to do is we're going to just look at examples of all three. We're going to put all three of these properties together and look at a few examples with this. Okay, so the first one. I have 4x squared y, and I'm raising that all to the third power, and I'm then going to multiply it times x to the fifth. So the first thing I'm going to do is I'm going to deal with this parenthesis over here. So again, I have to bring this 3 to all inside to all those factors. So let's do that. 4 cubed x, this squared times 3 would give me x to the 6th, y to the 3rd, and I still have this x to the 5th out here. You can put multiplication in between because you are multiplying these all together. Okay, well then I can definitely simplify this more. I have 4 to the 3rd. So 4 to the 3rd we know is 64. So this becomes 64. Well, look at what else I have going on here. I have an x term here and an x or a base of x here and here. Because they have the same base, if you go back up, first thing we did in the notes, I can add those together. So 6 times 5, or 6 plus 5, I'm sorry, x to the 11th, and then y to the 3rd. Again, just like we've talked about previously, when you have these variables like x and y and z, we want to make sure that when we list our answer that it's in alphabetical order. Because x comes before y in the alphabet, my x will come before y in my simplified answer also. All right, another example. I have 6d to the 4th. I'm squaring that, and I'm multiplying this by 1/4 d to the 3rd, and I'm squaring this. Okay, so I'm first going to bring out my exponents on the outside to the inside. So I have 6 squared times d, 4 times 2 is 8. And over here I have, I'm going to leave this as a fraction, 1/4 squared, and then 3 times 2 is 6. All right, well, let's look at my constants first. 6 squared, well, we know that 6 squared is 36. I have d to the 8th. Now I have a fraction, but do not be scared because squaring a fraction is easy. You just have to square the numerator and square the denominator. So I have 1 squared is 1. 4 squared is 16. So my fraction 1/4 squared becomes 1/16. And then I have d to the 6th. We're getting there. We're getting closer. Now I got to figure out, okay, well, I have 36 and 1/16. If I multiply those together, remember, you multiplied numerators and denominators, so I have 36 over 16, and then I have d to the 8th and d to the 6th. Since that's the common base of d, we can say that this is going to be d to the 14th. And last and finally, we know that we simplify all fractions. If I divide the top and bottom by 4, I actually get an answer of 9/4 d to the 14th. And that is my simplified answer from there. See, we started all the way back up at the top, Looks kind of complicated, but then we can simplify all the way down here to just a coefficient, variable, and an exponent. All right, let's look at another complicated example. This will be the last example, and you will work on this. Okay, again, this starts off, it looks a little complicated, but really, let's just stick to the rules. First thing I'm going to do is I'm going to bring this 3 inside to all the factors. Negative 3, notice the parentheses, cubed times x to the third, y, 2 times 3 is 6. Oh, this should be, hold on. This should have a squared out here. There we go. Okay. So, again, this squared is coming into all those factors. Negative 2 squared, x, 2 times 2 is 4, y, 2 times 2 is 4. All right, well now we're looking a little bit better. This is manageable. I'm first going to take care of my negative 3 to the third. If I do negative 3 to the third, I have negative 27. And then I still have x to the third, y to the sixth. Negative 2 squared is 4. X to the fourth, y to the fourth. Remember, these are all being multiplied by each other. Okay, well, I'm going to combine my negative 27 and my 4. I'm multiplying them, so that gives me negative 108. I then can combine my similar bases, x to the third and x to the fourth. I add, right? When multiplying, we add. So 3 plus 4 gives me x to the 7th. And then again, I have a y to the 6th and a y to the 4th. I have y, 6 plus 4 is 10, y to the 10th. All right, well, that does it from this video, and we'll practice this more in class.